All right. In the last few sections of the course, we created a very nice probability of default model. We tested how it works with unfamiliar data, and we created an easily interpretable scorecard based on it. Now imagine a year has passed since we implemented our model. A year is a long time, and a lot of things may happen. And although it's highly unlikely, the people who applied for a loan during this period may be very different from the borrowers whose data we used to build our PD model. That's why we need to reassess if our PD model is still working well. We should keep in mind that if the population of the new applicants is too different from the population of the borrowers used to train the model, the results may be disastrous. In such cases, we need to redevelop the model. The process of assessing your model in light of new data is called model maintenance. In reality, such assessments are often scheduled. For instance, every 6 months or every year. Alternatively, we may use the number of applicants as a benchmark. For example, we can redevelop our model after acquiring 50,000 or 100,000 new data points. All right. One of the most convenient and widely accepted ways to compare the two populations is using a specific measure called the Population Stability Index, abbreviated PSI. The main goal of the Population Stability Index is to determine whether the new data are too different from the original ones. It is very important to realize that time-wise, the new data were acquired sooner to the present moment. Therefore, our current borrowers and those to come are more likely to look like the new data we've acquired, rather than the old one we trained on. Okay, so how does PSI work? In light of assessing the population stability of our model, there are two populations. The first, or the original population, is the one we use to train the model on. The second population consists of all the new data we have acquired. We can take any discrete or continuous feature of applicants or borrowers and turn it into categories, in case it's not categorical. We've already seen how this is done, via fine classing and coarse classing. Say we have K categories of this feature. Of course, there's a certain number of borrowers or applicants that fall into each category. We can also look at the relative number or the proportion of borrowers falling into each category. Okay. Both populations are distributed in some way across the K categories of the feature. We can use the information about these distributions to assess if the populations differ with regard to this feature. For simplicity, we call the data from the new population actual, while the data from the original population expected. Now, how can we assess whether the two populations are different with respect to a feature? For starters, we should take the difference between the actual proportion and the expected proportion for any category J. Then, we multiply this difference by the logarithm of the ratio of the actual proportion and the expected proportion for any category J. And finally, the sum of these expressions for all K categories gives us the population stability index for this feature. So this is our formula for the population stability index. PSI takes values between 0 and 1. The value of 0 means there is no difference between the two populations. A value of 1 shows the two populations are absolutely different. So the closer to 0 the population stability index, the smaller the difference between the two populations. Commonly, we use the following table to summarize the different values PSI can take. If PSI is less than 0.1, there is little to no difference in the two populations. If PSI is between 0.1 and 0.25, there is little change, which requires investigation, but usually no action is taken. When PSI is above 0.25, we usually take the issue to heart and investigate further what the underlying reason is. In this case, the statistical model has to be rebuilt. Interpreting these values properly is very important, especially when it comes to assessing the population stability with respect to statistical model features, such as those from our PD model. Once we interpret the values and there are no changes in the two populations, we can keep using the original model. However, if there's been a significant change with respect to a certain feature, we will, most likely, have to rebuild the model. Okay, great. In the next lessons, we will get new data, pre-process it, and determine if our population has changed. Thanks for watching.